You are not living in the present. It might feel like you are, but the truth is a little stranger. You live in a hallucination of the next second. Your brain is a storyteller. It constantly crafts a narrative about what is about to happen, a fraction of a second into the future. It's a prediction, a guess. Your entire experience of reality is a stream of these rapid-fire predictions. This isn't some science fiction concept. It is the fundamental way your brain operates. It's a survival mechanism born from a simple, universal constraint: energy. Your brain is an astonishingly expensive organ to run. It makes up only about 2% of your body's total weight, a small, soft, wrinkled mass tucked safely away. Yet this small organ is a power hog. It consumes about 20% of all the energy your body produces, a disproportionate share for its size. This incredible energy demand means the brain cannot afford to be wasteful. It must be brutally efficient. To save precious energy, it has developed a brilliant trick. It doesn't passively wait for the world to send it information. Instead, it actively predicts what information is coming its way. This powerful idea is known as predictive coding, or sometimes the Bayesian brain hypothesis. It suggests your brain uses your past experiences, everything you have ever learned, to make the best possible guess about the present moment and the immediate future. It's like a sophisticated weather forecaster, but instead of predicting rain or shine, it predicts every sight. It predicts every sound. It predicts every sensation. It builds a model of the world inside your head. Then, it uses that model to generate a continuous, forward-looking simulation. This simulation is your conscious reality. It is your best guess about what is out there. So when you perceive the world, you are not just taking in raw data through your eyes and ears. You are actually comparing the incoming sensory information to the prediction your brain has already made. This process is happening all the time, billions of times a day, completely beneath your conscious awareness. It is the hum of the engine that drives your mind. The beauty of this predictive system lies in its energy-saving design. Imagine your brain is a diligent security guard watching over a vast, complex building. A guard who runs around checking every single door, window constantly would get tired very quickly. A smarter guard would learn the building's routines. They would know which doors are always locked, which noises are just the building settling. This smart guard only reacts when something unexpected happens. Your brain is that smart guard. It has learned the routines of your world and it trusts its own internal model to be correct until proven otherwise. This is the core principle. If the world matches the prediction, the brain stays quiet and saves power. When the sensory signals coming from your eyes, ears align perfectly with the forecast your brain has generated. There is no need for a massive computational effort. The brain essentially says, all is well. The world is behaving as expected. No need to sound the alarm. It doesn't have to process all that redundant information from scratch. It just needs a tiny signal to confirm that its model is still accurate. This confirmation requires very little energy, allowing the brain to devote its resources to other important tasks. Think about walking through your own home in the dark. You can navigate it quite easily, can't you? You don't bump into the sofa, coffee table. This is not because you are seeing with your eyes, but because your brain has a highly accurate predictive model of that space. It knows where the furniture is. It anticipates the texture of the carpet under your feet, distance to the light switch. Your brain is running a simulation of your living room, and as long as nothing is out of place, the simulation runs smoothly and quietly, consuming minimal energy. This state of quiet confirmation is our normal mode of existence. It is the seamless flow of everyday life where one moment logically follows the next without any jarring interruptions. It's the reason you can drive a familiar route while thinking about something else, or why you can listen to a conversation in a noisy room by focusing on one voice. Your brain is predicting the familiar patterns and filtering out the rest. Let's make this more concrete. Picture yourself walking through a shopping mall. Your brain is in full prediction mode, even if you are not consciously thinking about it. You see a clothing store you have been to before. In your mind, you already have a model of this store. You predict the layout, the type of music playing, and the general style of the clothes. You spot a pair of pants on a display table. Instantly, your brain generates a cascade of predictions based on countless past shopping experiences. It predicts the fabric will feel like denim, the cut will be a familiar style, and the price will be somewhere around $50. It's denim, just as predicted. The style is a classic straight leg cut. Another match. Your brain notes these small confirmations without any fuss. It might adjust its model slightly. Perhaps the shade of blue is a little different than expected, but these are minor updates, not alarms. Your brain's model has a strong prediction. The price will be about $50. If the tag says $49 or even $55, it is close enough. The prediction is largely correct. Your brain stays quiet. But what if the price tag says $75? Suddenly, there is a significant clash. The incoming information from the real world violently disagrees with your brain's prediction. This mismatch is what scientists call a prediction error. It is a moment of surprise. When a prediction error occurs, your brain needs to react fast. It cannot afford a long delay to figure out that its model of reality is broken. To handle this, it has specialized neural hardware. Deep within your brain are unique, large neurons, von Economo neurons, spindle cells. You can think of these cells as the brain's high-speed information highways or fast rails. They transmit urgent signals across long distances much more quickly than standard neurons. They are the express train for important news. When that jarring surprise of the $75 price tag hits you, these spindle cells leap into action. They are central to broadcasting the prediction error signal. Neuroscientists have observed that a significant prediction error triggers a distinct short burst of electrical activity in the brain. This burst is incredibly quick, lasting only about half a second. It is a powerful, system-wide alert. This electrical spike is not an emotion itself. It is the raw signal of surprise. It is the brain's emergency broadcast system. Attention all units. We have a deviation from the expected reality. All non-essential processing. Stand by. I need more cognitive resources now. This half-second burst is a call to arms for your cortex, the thinking part of your brain. It pulls your attention from daydreaming and focuses it on the surprise. The brain diverts power to analyze the new information. The spindle cells ensure this happens in the blink of an eye. Once the spindle cells have sounded the alarm and your brain is paying full attention, the surprise signal needs to be interpreted. Is this unexpected event good or bad? Is this a danger or an opportunity? This critical judgment call is handled by a small, almond-shaped structure deep in the brain called the amygdala. The amygdala acts as the brain's rapid response emotional evaluator. It receives the surprise signal, quickly assesses its potential meaning, deciding whether you should feel fear, delight, or something in between. It is the gatekeeper that turns the raw signal of surprise into a meaningful emotional experience. Let's go back to our shopping example. The $75 price tag was a surprise. The amygdala now has to decide what that surprise means. In one scenario, your brain might interpret this high price as a potential scam. Stitching looks cheap, store reputation shady. Your amygdala flags this as a potential threat. It triggers a cascade of physiological changes associated with the fight-or-flight response. Your heart rate might increase slightly. You might feel a sense of unease or suspicion. You instinctively want to step back. But let's imagine a different scenario. What if you realize the $75 pants are from a famous luxury designer brand that normally sells for $500? The prediction error is the same, but the evaluation is completely different. It now interprets the surprise as a massive opportunity, a fantastic reward. Instead of a threat signal, it helps trigger the release of dopamine. You feel a rush of excitement and want to grab the pants immediately. This rapid evaluation process is a cornerstone of our survival. For our ancient ancestors, a sudden rustle in the bushes was a prediction error. Is it just the wind, a neutral event, or a hidden predator, a mortal threat? A quick, accurate judgment meant the difference between life and death. The same ancient wiring is at play when you react to a sudden loud noise, a pop-up ad on your computer, or an unexpected compliment. The amygdala takes the raw data of surprise and colors it with emotional meaning, guiding your behavior towards safety and reward. This is how your brain navigates a complex world. Fast, efficient predictions with rapid reallocation of energy when the unexpected arrives. The brain's predictive machinery is running your life every second. You can find evidence of it everywhere. One compelling example is hiding in plain sight. In a lack of sight, each eye has a blind spot, a small area on the retina where the optic nerve connects. There are no photoreceptor cells there, so you're technically blind in that spot. Yet you never perceive a black hole in your vision. Why not? Because your brain predicts what should be there and fills in the gap. If you're looking at patterned wallpaper, your brain predicts the pattern continues and paints it in. Your perception isn't a perfect photograph. It's an edited, completed picture created by your predictive model. This filling in proves you see the world as your brain expects it. Most people don't even know they have a blind spot until it's demonstrated with a test. The same mechanism explains why we love plot twists in movies and books. Predictable stories feel boring. There are no prediction errors. A shocking twist generates a massive prediction error. The hero you trusted was the villain all along. The reality you thought you were watching shatters. That creates a burst of neural activity, a jolt of surprise. It forces your brain to update its model. That excitement and satisfaction is your brain rebuilding its understanding. It's a form of cognitive pleasure. Surprise re-engages your attention and makes the story memorable. So what is the ultimate takeaway from this journey into your predictive mind? It is a simple but profound one. Surprise is the mechanism that recharges and refines your model of the world. Your emotions, particularly the jolt of surprise, are not just fleeting feelings. They are essential tools for learning. They are the signals that tell your brain when to pay attention, when to question its assumptions, and when to update its internal map of reality. Without surprise, your understanding of the world would become stale, outdated, and dangerously inaccurate. Your brain would be stuck in the past, unable to adapt to a changing environment. We are, in essence, prediction machines living in a carefully constructed hallucination of the immediate future. This system is designed for maximum efficiency, allowing us to navigate a complex world without being overwhelmed by a constant flood of sensory data. For most of your life, your brain hums along quietly, its predictions aligning with reality, saving precious energy. It's a smooth, seamless experience, but life is full of the unexpected. And when the world defies your expectations, your brain has a beautiful, elegant system in place to handle it. The prediction error is the spark that ignites the process of learning. That brief half-second burst of neural activity carried along the fast rails of your spindle cells is the most important moment in this whole process. It is a biological command to stop, focus, and reevaluate. It is the moment your brain admits, "I was wrong," and opens itself up to a new piece of information. The subsequent emotional coloring from the amygdala then guides your response, pushing you away from perceived threats, pulling you toward potential rewards. This entire sequence, prediction error, emotional response, model update, is how you grow and adapt.